So in this we are going to discuss about the Artiflex structural components and its location, then piston crown, piston ring groups, this will be our discussion, how the design aspect of the new piston ring and piston rod in this engine has been improvised. We will discuss also the cooling arrangement of the piston, which more or less remains same as RTA, but we will also discuss on this. Thereafter we will touch upon the cylinder liner and the jacket arrangement, the bed plate design and the crankshaft, how it looks like in the Artiflex engine, and then once again we will just go through the various rails position on the engine column, that in a real engine where this component looks like and this position. So let's discuss. This is the Artiflex engine.
Are your promotions slow? Not getting the respect that you deserve on board ship? If you are a marine engineer who is looking for faster promotions and earning respect on ship, then don't worry, Merchant Navy Decoded has your back. Introducing excellence packages for every rank now. You want to learn about purifiers, compressors, electronics, automation, MEGI engines, Artiflex, ME engines. Don't worry, we are there. Learn anytime, online, offline, whether you are on land or on board ship. Engineers who invest on upgrading themselves, they lead. What are you waiting for? Go to the description box and you will find different ranks, different excellence packages. Start investing now. Jai Mata.
These are the cut view of the Artiflex engine, which you can see here. And as I had discussed earlier, that in a bigger engine where you have more than 6 cylinders, the supply unit and the servo supply unit will be located on the mid position, and for a smaller engine this is located near the flywheel. In both cases the drive is taken from the main crankshaft only via gear, and this is the unit which is supplying the fuel at high pressure and the servo oil at high pressure. This is the cut view in which you can see that the piston rod, crosshead, connecting rod, crankshaft and the bed plate portion. So we will continue our discussion on piston now. So the Artiflex engine operates below the NOx limit. We have shown earlier in our discussion the graph, and why it is operating below the NOx limit set by the IMO, because of the flexibility in the design and optimization of fuel injection and exhaust valve actuation by introducing the common rail and the electronic control principle. That is the backbone of the principle on which the Artiflex engine works, and this feature gives this benefit of this engine, that this engine remains smokeless even at very low load, and the engine operates below the NOx limit which is set by the IMO. In this engine, when IMO come up with tier 1 criteria, that is the time this engine was performing below the limit what IMO had set. So these engines perform smokeless operation at all RPM. In earlier version, in a mechanical engine, the engines were not able to operate smokeless because of the complexity or the compulsion of the cam and the camshaft arrangement, which was badly affecting the fuel injection at lower load, which is completely overcome in this electronic engine. The superior combustion with common rail system is because of the fuel injection pressure, which is maintained at all RPM irrespective of the load change or RPM change, which was not feasible in case of a cammed engine, which was very much the big drawback of a cammed engine, where the RPM was going to activate or actually decide the injection pressure, and that is the reason in those engines at lower load the injection was very badly suffering at lower load. So in this engine Artiflex, there is another very unique feature has been adopted by VEX control system, that out of 3 injectors only 1 injector will work at lower load, and in this way it will perform at full load condition, 1 injector, and this injector will keep on switching to different injector progressively to ensure that other injectors are also remain within the stress, and the cooling is also done since they are not inoperative for a longer period. So at lower load condition, the injectors are also switching to different one as per the direction from VEX controller. The engine structure design is based on stress and deformation calculation carried out by using a three-dimensional finite element analysis model, so that the stress part is very much made very stronger, and wherever the stress is not so much, those parts can be made lighter. And this is the reason the Artiflex engine is having superior power to weight ratio as compared to the previous model. This is the picture which is showing the piston ring and the piston ring group profile, as you can see here. What is the special in this piston ring? We had discussed in general in earlier sessions also that the pre-profile piston rings in all the groups, we are having a different profile of the piston rings in all the groups and not only on top. Chromium ceramic coated pre-profiled gas tight piston ring in the top piston ring group. This top piston ring group is going to sustain the maximum gas pressure, and this is the piston ring which is working under most arduous condition. That is why every engine maker is giving special attention to the top piston ring, how it performs, because as long as this top piston ring is in a very good condition and doing its job, the remaining piston rings will be less stressed and the lifespan of the piston ring will be also prolonged. That is why here there is a special design they have introduced in Artiflex engine, the chromium ceramic coated, which makes it more polished as well as more arduous to very high pressure and temperature. Running in coating. As you all know that whenever we are starting with a new piston ring or liner, there is some running in phase provided that will ensure the even wear down of the piston ring profile. So in this case, they have given a special coating on top of all piston ring, which is called running in coating. And running in coating is going to help the phase during which the RPM is very well controlled whenever we are going to run this engine in running in phase. So this running in coating ensure that the piston running in is carried out in a very controlled manner, and this is going to enhance the life of the piston ring thereafter. Introduction of anti-polishing ring is a new thing again in Artiflex engine, which is added on top of the cylinder liner, and the role of anti-polishing ring is to clean this portion. This is the top part of the piston crown, which we call high top land. So this area there is lot of chances of carbon buildup, and this is going to scratch the liner, and this is going to affect the cylinder liner lubrication as well. That is why cleaning this part is extremely important in designer's mind, and that is how they have introduced the new anti-polishing ring. And this anti-polishing ring is having little bit oversize than the liner bore, but it is definitely going to give a clear passage to the piston. So whenever the piston is passing across this anti-polishing ring, there is a small gap which is left over, which is going to govern that the piston ring and the anti-polishing piston top and the anti-polishing ring should never come in contact, and only the carbon layer is going to be cleared off during the upstroke or downstroke. So in this way, this job of this anti-polishing ring is to do the cleaning part. Every time it come across with the piston crown, it is going to scrap the carbon accumulation, and in this way we are going to keep this area clean, and this will improve the cylinder liner condition, the cylinder lubrication condition, and ultimately it will enhance the overall life of the engine component, which is piston as well as piston ring. That is why the role of anti-polishing ring is now an integral part of all modern engine, and this is compulsorily given in all high top land piston design. Then another improvement they have made is increased thickness of the chromium layer in the piston ring groove. So the piston ring groove is also getting suffered because of high peak pressure and temperature, since these engines are highly rated. So in this new design they have made this piston ring groove also more stronger now. And how they have made? By increasing the thickness of the chromium layer, which is a very hard metal, which ensures that this thickness which is increased now is not going to make the base metal in bare condition, and this is going to protect the base material on the back end from all the hardest condition this piston ring is going to face, or the piston is going to face. That is how this new design has made a drastic change in the running performance of the piston and its associated components. This is the picture of the piston and the piston rod along with the stuffing box arranged of Artiflex engine, and you can see overall the design of the piston ring groove and the piston rod, which are made in a much better way. The material quality has been improved, the material is more harder and it is more prefined to face the harsh temperature and pressure condition in this highly rated engine. The piston comprised a forged steel crown with a short skirt. Combined jet shaker oil cooling of the piston crown provides the optimum cooling performance. I am sure all of you are aware that these pistons are cooled by oil which is supplied from the main system oil itself, and the cooling method employed in this engines is called jet shaker method. We will discuss more in detail how the jet shaker profile is made by intense cooling, and in this way the material remains within the stress limit and it does not deteriorate. So this is how the piston crown design is made, and it is a two-piece design. So it means that there will be a piston crown and there will be a piston skirt which are joined together and made a piston unit, which is a composite design. Then it gives very moderate temperature on the piston crown with an even temperature distribution right across the crown surface because of the piston crown profile as well as the cooling media or the cooling design which this engine has been provided. This is going to give an even cooling surface, and in this way none of the piston part will be in a stressed condition under this very harsh condition. The design measures applied to improve the piston running behavior includes the liner naturally also has to be very appropriate material, careful turning of the liner running surface and plateau honing of the liner. The liner honing design has also been changed in this Artiflex engine because it is working under more intense temperature and pressure now, and the cylinder oil film must be retained under all conditions, and that is why the honing is a special design in Artiflex engine. The mid-stroke liner insulation is further improvisation in this Artiflex engine to ensure that liner cooling is also remain within the limit and none of the surface of the liner is overstressed because of high temperature. Gondola type of bed plate surmounted by a very rigid A-shaped double wall column and cylinder block, all are secured by a pre-tensioned vertical rod which we call tie rod. We will discuss when we will show the picture. that how this individual components are tied together by tie rod, and these are pre-tension, so that when engine is getting expanded because of high temperature and pressure, the component should not shift from its position. The whole structure of the engine is very sturdy with low stresses and high stiffness. Both bed plate and columns are welded fabrications which are also designed for a minimum machining. The A columns are also fabricated, but machining is very minimal. These are the design features of the piston and the individual component. This is the inner view of the piston crown. This piston crown is having this profile which is embedded. Specifically they are given for the cooling channels. Here the jet which we are going to create by a special mounting, we will show in the next slide, that this jet will strike the oil into the inside surface of the piston, and in this way it is going to give an intense cooling effect and taking the heat away from the top surface, which is under the influence of very high temperature and pressure. So this special design which is profiled under the crown is going to create a additional cooling surface. At the same time, it is going to allow the oil jet to strike at exact point where the temperature will be very high, and this way the heat extraction will be more efficiently done. These are the points given which is for the studs to secure the skirt with the piston crown. So this is one piece of the piston. Then there will be another piece of the piston which we call piston skirt, which is coming next to this, and both these pieces are secured by the studs hydraulically, and this way the composite piston will form one piece design. This is the next part of the piston which we call skirt and the cooling jacket design, cooling shaker design. These are the set of nozzles which is going to inject the lube oil at normal temperature, which is coming from the system oil, and these jets are getting fitted into the profile which we have shown just earlier in the slide, that these nozzles are getting fitted inside this hollow column which is created under the piston crown. So when we are fitting it together, these are the holes which you saw in the crown also, which will be connected together, and once we are mounting it together, this jet will go inside this hollow column which is inside this piston crown, and when the lube oil is coming via the piston rod through this jet, this is getting sprayed inside this column, and because of this spray, the top portion of this crown, which is highly stressed and very high temperature, these are the hollow column and this is the piston crown surface. So this surface is under the influence of very high temperature and very high pressure. So to retain the strength of this portion is a big challenge for the designer, and that is why they have given this kind of design, so that from inside we can strike the oil jet, on these surfaces very closely to take away the heat in a much faster way, so that this material will not be very much stressed and it will not deteriorate. That is the role of this jet shaker cooling method which is employed in Artiflex engine for enhanced cooling. Then this portion is called skirt of the piston. This is the second piece of the composite piston in Artiflex engine. This is the skirt, and these are the soft ring which is embedded on the skirt, which are made of very soft material, bronze, and this is just serving as a guiding ring, and this is inbuilt, not like your piston ring. These are inbuilt on the skirt of the piston, and this is going to create a very smooth surface on the liner when it is coming in contact, and it is not going to cause any kind of abrasion or any kind of wear down to the liner. That is why the skirt is remaining in contact with the liner via this soft ring and not directly on the base metal, which is made of much harder material. That is how the overall design of the Artiflex piston goes. So I hope you are clear about the new design which is introduced in Artiflex engine, about the piston crown, the inside hollow columns which are designed for enhanced cooling, and the skirt which is having this jet shaker arrangement. And this design is not very new, this is coming from Artiflex. Only thing is that here they have made much better analysis about the stress concentration and the cooling enhancement, because these engines are highly rated as compared to Artiflex engine. Thank you very much.